The radar was set to 12 nautical miles in range. Set to north-up orientation. And we will be doing the 6 minutes plot, or the 10th rule. Disclaimer. This video content fits only for the purpose of this study. First observation of the target, at 1400 hours, was at 039 degrees. With a range of 10 nautical miles. After 6 minutes. The target was observed at 1400 hours, 6 minutes. Bearing of 037 degrees, with a range of 8 nautical miles. Gather all the relevant information, and plot it to the radar transfer plotting sheet. To locate the CPA, and to calculate the CPA distance, CPA bearing, and the CPA time. So, what are we waiting for? Let us now proceed. Plot the on-ship data. Course is equal to 000 degrees true. Speed is equal to 20 knots. Draw a ship at the center of the radar transfer plotting sheet to be the guide for the plotting process. Plot the target ship data. The bearing is equal to 039 degrees true. The radar was set to 12 nautical miles. So therefore in the radar transfer plotting sheet, we will be using the 12 nautical miles scale. Using the compass divider, measure 10 nautical miles. Then bring it along to the target bearing, starting from the center of on-ship. Then at the end of the measured range, mark it with a dot. Label it R, to indicate that this is the first plot of the target at 1400 hours. Plot the target ship data. The course is equal to 037 degrees true. And the range is equal to 8 knots. Measure it using compass divider. Same procedure, what we did in the first target ship plotting. But this time, label it M, to indicate that this is the second target at 1400 hours, 06 minutes. Connect the marked targets observed, passing the on-ship, at the center of the radar transfer plotting sheet. And label it RML. Draw a line from the center of on-ship, perpendicular to the RML. The intersection is the CPA, stands for the closest point of approach. Measure the range using the compass divider. Bring it to the 12 nautical miles scale. And it reads 1.2 nautical miles. Measurements in this video presentation is less accurate to the actual radar transfer plotting sheet. What is necessary is the methodology. Extend the line of the CPA distance to the last ring of the radar transfer plotting sheet. And the relative bearing of the target at her closest point of approach, it reads 315 degrees. The first target range was 10 nautical miles, taken at 1400 hours. The second target range was 8 nautical miles, taken at 1400 hours, 6 minutes. The distance is equal to 2 nautical miles, and the time interval is 6 minutes. The formula is SRM, stand for speed of relative movement, is equal to distance divided by the time interval. And it goes in this way. 2 divided by 6 is equal to 0.3 with a vinculum. Press second function, then press degrees, minutes, and seconds. The result, 0 degrees, 20 minutes, and 0 seconds. The unit of knots is miles per hour, so therefore that would be equal to 20 knots. The range from the last target observed to the center of the on-ship is equal to 8 nautical miles. Apply the formula, steaming time is equal to distance divided by the speed. And so it goes like this. 8 nautical miles divided by 20 knots. The result is 0.4. Press second function. Then press degrees, minutes, seconds. The result is equal to 0 degrees, 24 minutes, and 0 seconds. 1400 hours, 6 minutes, added by the steaming time. The result is the CPA time. Let us now do the addition. 1400 hours, 6 minutes. Added by 24 minutes. The result is 14.5. press second function, then press degrees, minutes, seconds. The result is equal to 1400 hours, 30 minutes, and 0 seconds. Where did I get 2 nautical miles? I measure it from the range of the first target observed to the second target observed. Or from R to M. And how about 8 nautical miles? I measure it from the last target observed to the point of the CPA. Or from M to CPA.
Thank you for watching. Please subscribe, and click the notification bell, for you will be updated for our next upcoming video.